You ever wonder what computer code actually is? Like, what's really going on under the hood? Well, today we're going to pull back the curtain and look at the basic blueprint for one of the most important programming languages of all time, C.
So what does a program's blueprint actually look like? The best way to figure that out is to just build one. We're going to become the architects here and put together a simple program piece by piece, so you can see exactly how it all fits together.
Okay, so just like any building needs a solid foundation and, a front door to get in, every single C program needs a starting point. And in C, we call that the main function.
And this is it. This is the absolute bare minimum, the non-negotiable heart of any C program. I know it doesn't look like much, right? Just a few symbols. But ent main, that's the name of our official entry point. And those curly braces, think of them like the walls of a room. They create a container where we're going to put all of our instructions.
It's kind of like the starting line in a race. You can have all sorts of other stuff in your code, but it doesn't matter. The computer is hardwired to go right here first. It's the one mandatory spot where all the action kicks off.
So here's the key takeaway, right? The main function is the boss. It controls the entire life of our program. It's where things start and it's where they end. The computer runs this first, and as soon as main is done, poof, the program is over.
All right, so we've got a structure, we've got our container, but it's just an empty room right now. It can't actually do anything useful. To make it do something, like, say, print a message on your screen, it needs some tools to talk to the outside world.
The good news is we don't have to build these tools ourselves from scratch. That would be a huge pain. Instead, C lets us just import these pre-built toolkits. We call them libraries, and they're just packed with all sorts of useful commands for common jobs.
So this line here, this is a really special kind of instruction. It's called a preprocessor directive. The pre part is key. It means this happens before our program even starts to run. Think of it like leaving a note for the construction crew. Before you start building, you tell them, hey, go grab this specific toolbox. In our case, that toolbox is the standard input/output library, or stdio.h, and it's got everything we need to print stuff to the screen.
Okay, so making our program actually talk is basically a three-step process. Step 1, we import that stdio.h toolkit with our hashtag include line. Step 2, we grab a command from that toolkit, printf, and use it to write our message. And then step 3, we finish up with return 0. You can think of that last part as our program giving a thumbs up to the computer, basically saying, hey, I'm done and everything went off without a hitch.
Awesome. Our program can communicate now, but what if we want it to remember something? Let's give it a little bit of memory and then tell it what to do with what it remembers.
And that's where something called a variable comes in. The easiest way to think about a variable is just as a labeled box. It's a little container we create in the computer's memory, and we can stick stuff in it for later, like a number, a letter, whatever we need.
Now this line of code here is how we create one of those boxes. It's called a variable declaration, and it's got 3 pieces. First, you see that int? That tells the computer what kind of box to make. In this case, one that can hold an integer, a whole number. Next up is a. That's just the name we're slapping on the box so we can find it again. And finally, the equals 10 part is pretty straightforward. It's just us putting the number 10 inside our newly labeled box.
And this table really nails the difference between the 2 big ideas we've covered. On one hand, you have a variable. Its whole job is to store data. It's all about memory. On the other hand, you have a statement, like our printf command. Its job is to do something, to perform an action, usually with that data. So yeah, one is for knowing, the other is for doing.
All right. We've laid the foundation, we've put up the walls, we've even put some furniture in the room. I think it's time to step back and take a look at our finished blueprint. And there it is, our complete program. You can really see the flow now, can't you? It starts right at the top, telling the system to grab our toolbox. Then we step inside the main function. Once we're in, we create our little memory box, our variable. Then we perform an action using that variable. And finally, we make a clean exit. It's a perfect logical sequence.
This chart gives a great visual breakdown, doesn't it? It's like the anatomy of our tiny program. You can see how all the pieces we talked about, the preprocessor, the main function, the variable, and the action part, each have their own job, but they all have to work together to make the whole thing run.
And really, the big thing to take away from all this is that even the most complicated software you use every single day, I'm talking games, apps, everything, it's all built from these same simple, logical pieces. It's all just building blocks, stacked on top of each other.
So if what we just built is the blueprint for a simple sentence, what does the architecture for an entire application look like? Well, that's a question for another explainer. I really hope this peek behind the curtain has made you a little more curious about the amazing, complex worlds that are built from these very simple starting points. Thanks for watching.